Okay, I'm going to start. Last time we just left in discussion about usability labs and user testing. This is an example of usability lab where you have one-way mirror window which is practically the most, which has been the most important part of the usability labs, but today, due to the advance of high-quality camera systems and inexpensive camera systems, what we do is basically we use two rooms, and many usability labs do not care about mirrors unless it is extremely professional. The idea is to give tasks to users and observe users and record the performance and try to understand the correlation between the actions and the results. So concepts like ease of use, what is easy, what is hard, must be measured. You cannot conclude automatically that a good-looking software, nice-looking software, graphical objects are easier to use. It is wrong. You have to measure it. You have to measure that it is easy or it is hard. You cannot immediately say that. So keep that in mind. So let me start. So this was the last week's last slide. Today I'm going to go through mental models, and then I will start discussing about the properties of good user interfaces. So we will discuss about properties of good user interfaces. Therefore, when designing our user interfaces, designing our systems, we will try to follow general guidelines which has been described by many scientists and researchers. The first thing is, interesting thing is the mental model. For example, my mental model says Ömer Faruk is listening to me because Ömer Faruk is looking at me. So human mental model says if somebody is looking at you, he's probably listening to you. But if Ömer Faruk turned off the sound and doing something else, maybe he is not listening to me. On the other hand, my mental model says it is the opposite. My mental model says he is listening to me. So how am I going to say that? Because of my past experiences, because of the visual cues that I get. For example, we have other friends listening to me, and I conclude that they are paying attention because of the visual cues. That's why I want to have students with cameras turned on, because when the cameras are turned on, my mental model about the class becomes more realistic. If you don't have any visual cues coming to me, then my mental model cannot construct a classroom image. Therefore, my performance is reduced. So the definition of the mental model is the mental image that users develop that is influenced by the real-world experiences and the experiences with other objects and applications. For example, what is this? That's probably a music player or some sort, or either CD player, MP3 player, some kind of player. How do I know it? Because there are play, forward, backward buttons, fast forward, stop, right? And some minutes, and there's a left right fader adjustment and some information, and moreover it says 44 kilohertz, and 44 kilohertz is associated with audio, etc. So I realize that I conclude that this is a music player. When I conclude that this is a music player, my actions forms my actions form based on that model. For example, if I think that it is a refrigerator, I will act differently. Or if I think that it is a control panel of a communication device, then I will act differently. Maybe I won't act at all. But this looks like a MP3 player which I have seen before. Therefore, the mental model is constructed so that I can use based on my mental model. So as we learn, this is important, as we learn, we look for patterns that can be used to predict future outcomes. For example, a lever. So forward, backward. So based on our previous experiences, when you push something forward, it moves forward. When you push something backwards, it moves backwards. So this is our previous experience. Many of the previous experiences tell that. Or here's a gauge. Okay, this gauge shows the pressure. So in order to have the pressure increased, I need to see the needle moving. So my mental model says needle has to move to some certain position. So my use of the device, my use of the interface is formed by those past experiences. However, even if we get the education, our mental models are often incomplete and sometimes superstitious. For example, what is your mental model about artificial intelligence? What is your mental model about ChatGPT? What kind of machine we have at the back of the ChatGPT? What happens? What kind of algorithms? For example, a pointer in C programming language. Many of you are familiar and mastered with C programming language, but the way you use pointers is highly affected by your mental model about the memory organization, about how pointers work, about how memory access is performed in the machine. So your use of the pointer, the way you use the pointers, is different from person to person sometimes because their understanding, their mental model is different. So we use the interfaces and we use for example, the World Wide Web or the Microsoft Teams based on our understanding. So our understanding is called as the mental model. They are often incomplete and sometimes more than necessary. They include some additional capabilities which doesn't exist. Many people think that artificial intelligence is intelligent, very intelligent, but It's not like that. Also, some other people say human brain has no limit. But researchers found out that it has a certain capacity. It's very high, but it's a certain capacity which never fills. And since it is analog, we don't feel that the capacity is full. So old knowledge gets erased slowly as we learn new things. So our actions, therefore, are based on our mental models. The mental model of a device, find the device. This is Raspberry Zero. The mental model of a device is formed largely by interpreting its perceived actions and its visible structure. Its visible structure tells me that it has it has one HDMI port, two USB ports, and one SD card, and some other ports. It says, okay, I am going to connect it to an external monitor. My actions are formed by visual appearance because I have seen it. So if a user is making mistakes, it is due to the incorrect mental model because user or the person believes that what he or she is doing is correct. Nobody is eager to make mistakes. Nobody wants to make mistakes. So as you do mistakes, you believe that it is correct. How do you believe that it is correct? Because your mental model uh, says so. In the elevators, okay, there is an up arrow and there is a down arrow. I have seen one woman in the first floor repeatedly pushing this button, down button, in order to go up. One day, I talked to her and asked, why is she pressing down arrow in order to go up? Okay, from the ground floor. She said the elevator is an upstairs and she is trying to call it down. So in order to call the elevator down, he told me that you have to press down arrow. So that is what her mental model, and she was acting based on the model. There is an explanation of that, but that means this interface for some people is not adequate. Then they put some explanations next to the interface to reduce the problems, not eliminate, but reduce the problems. However, when you have explanations, then the interface is not good. Okay? Interface is not good. Oops. My connection is gone. Wait a second. What? Hold on a second. Okay. Hold on. Bir dakika ya. Unable to connect. Şöyle yapayım. Kalem gidecek ama. Okay. I think it's done. I have connected my second monitor. I've connected my second monitor without the tablet. So by understanding the mental models, we can predict user behaviors. We can explain user behaviors, and we can understand errors. Why did the user made this error? We can understand. We have a nice example. I made a study about two types of refrigerators. One of them is Beko. One of them is Vestel. Two different brands of the refrigerators have two different interfaces for the people. And two different interfaces were radically different and resulting in various confusions. And I'm going to explain those confusions. This is Vestel, one brand, and has a left and right control for two different compartments. The left part controls the freezer, and the right part controls the refrigerator part, cooler. So aside from having it in English, because people in this country is speaking Turkish, so there is a language issue in the interface. Let's keep that separate. And there is a clock in the middle, which is never set up. So it always blinks with 0 or 12. In this interface, our mental model is formed largely by left and right part corresponding to top and bottom parts. And the things that you see the things that you see here are lights. So as you keep pressing the button here, this moves up. As you keep pressing the button here, this moves up. And after 8 or 9 pushes, it starts from the beginning. So it rotates. Fast cool and fast freeze illuminates these parts. Basically, they are maximum setting for a certain amount of time. So using this interface, I will have some mental model forming. In the Beko, it's different. There is one outside and there is one inside. The inside one has multiple, this is rotatable wheel, and it has some notes on it, and you are understanding that 10 is the maximum, 1 is the minimum. So you rotate this wheel, mechanical wheel, based on that information provided inside. And you realize that this is the freezer. And the outside, there is a panel, and this panel, you can change the amount and degree at the same time, maximum cooling, minimum cooling. Although the value is increasing, it's blue, value is increasing, the number decreases. So it is opposite because it is minus. But in this one, there is only one setting outside, only one. And another from inside. This is interesting. So the first model, Vestel, okay, first model, Vestel, creates this kind of illusion. You have a freezer and you have a cooler. You have a control for the freezer and you have the control for the cooler separately. So some cooling unit is controlled by controller. Another control unit is controlled by another controller. This is my mental model. This mental model creates actions based on independent control of freezer and fresh food. People believe that there are two different sections and not connected and act based on that interface. However, it is incorrect. There is only one compressor. In reality, there is one cooling unit. Only very expensive coolers and refrigerators have two different units, separate units for freezer and the fresh food section. Generally, they only have one. In the Beko, you have a freezer and fresh food section, which is controlled by a mechanical valve, which is control B, inside the freezer, and then another outside control, which is connected to the thermostat and controlling the cooler. So this is the model that Beko interface forms, which is more logical, because my mental model in this case assumes that there is only one engine. Two different engine perception is eliminated. Let me show you some interesting thing. Okay, for example, oops, where is mine? Okay, this is an ad video link from the YouTube. It says a car that charges itself. So when you see that the car is charging itself, what is that? So based on this, based on the information provided, charges itself. Your mental model says, then where does it get the electricity and so on? So some people believe that it's going to be cheap, etc. But actually, it's a serial hybrid technology. It's a hybrid technology, but incorrectly marketed as an electric car, and therefore creates an incorrect mental model in the minds of the consumers. So our mental models are formed based on the information we provided. In the interface case, the interface elements create this mental model. So about the refrigerator, I want to leave the things in the freezer frozen, but the fresh food section is empty. I can turn it off. Is this possible? With the mental model of the Vestel in the first example, it is possible. But is it possible in reality? No, it's not possible in reality. In reality, they are connected and there is only one engine. Second mistake, I'm not using freezer. Maybe I can use freezer as a fresh food compartment after increasing the freezer temperature above zero. So let's make it both fresh food section. Can I do it with the mental model 1? No. With the model, yes, but in reality, no. So improper mental models will result in unexpected problematic uses. And I have a good news. Arçelik has another Beko brother company. It's actually the same company. Arçelik has a model, also Beko, has a model that provides this capability. So this question and this question has been addressed in a new model refrigerator, technically, so people can use it this way. But the models I have shown to you, this one, it didn't provide that kind of capability, but the interface resulted in that kind of use. So designers and engineers therefore must create products that are parallel to users' mental models, not theirs. Mental model of designer should be consistent all the time. It should not change from model to model. Otherwise, if the mental model is not consistent, users will follow their artificial mental model and they will make mistakes. For example, this is a classroom, okay? And there is a white screen. In order to make screen up and down, you have switches. You have switches here, switches here, switches here. So which switch should move it up and down? Basically, what you expect is it has to be somewhere here or here. No. Incorrectly, it is placed here due to technical problems. And all the time, this is from United States example, all the time people make mistake because your mental model says the control for the white screen must be closer to the white screen. Control to the lights must be closer to the other window. But when you do the opposite, when the designer model does the opposite, people fail all the time. So it is a design problem. If the operation is consistent with the mental model formed by the interface, for example, what does this button do? There is an arrow. Maybe you will think that it's play, but play is P. It's an old device. Record is R, and stop is associated with S. So in those years, they didn't even form the icon symbols yet. So it is the early years. Arrows are starting to form, but not as much. So text labels are more preferred in the early days of the technology. So if the mental model results in expected outcomes, the model is strengthened. So you have better model because it works fine. And user continues the system with more confidence. If the model is wrong, for example, in this one, CD player controls are closer to the tape controls are closer to the CD. So this is another general old example that we give all the time. Somewhat related to the Gestalt principles. Proximity makes correlation. So proximity of those buttons automatically creates correlation between the buttons and the function. But since the places are wrong, then you will have trouble finding the correct buttons. And at the end, you need to provide additional text explanations with it. Again, for example, what is this button for? This button is going up, something like that. But based on the previous experiences we have lived through, that's probably back. back button. Okay. Oops. That's probably the back button. For example, what is this for? How do you use it? That's probably on off. But how do you use it? Your mental model says, based on the previous experiences, you need to press for 2 seconds. When you press 2 seconds, it's going to turn off, it's going to turn on. Otherwise, it's going to function as an enter. So long press, short press action is formed by our previous experiences. Okay. This looks like a combination for cursor control or menu control. So if it is only one, I will recognize it as a hazard lamp. Dörtlü flasher in Turkish. But when you have 4 of them pointing on the other directions, then you realize that it's not a triangle anymore. It is arrow for the directions. If there is only one, it doesn't work that way. So our mental model forms through the interface. If the mental model results in unexpected outcomes, we develop new mental models and behave accordingly. We say, maybe it doesn't work that way. And try to understand, try to form new mental model because we want to use it. We have to use it. Then, through the second mental model, we try our second chance. If it goes well, then we have found the correct model. Otherwise, we are moved into uncertainty without knowing what to do. And we say, computer is not functioning. Computer is gone out of its mind, etc. So not thinking that our mental model is incorrect. We believe that the computer is not functioning correctly, which is perfectly understandable because nobody believes that, nobody wants to believe that he or she is wrong in terms of the model. Because when you are wrong, you don't understand that you are wrong. Otherwise, you won't be wrong. So nobody knows that they are wrong indeed. Everybody believes that they are correct. Any questions? Okay. So, based on the visual appearance, we choose what to do. Assume that you have seen an emergency button like this, and there is an emergency, and there is a key. So, when you look, what do you think? Is it locked? So, this is interesting. So, visual appearance is actually determines your decisions about how to proceed. For example, you will have a homework about reading Donald Norman. I am going to assign it to you this weekend. And in the book, it talks about affordances. For example, please click me. Blue font, underline, blue font, underline, is associated with hyperlink. Unfortunately, some people omit that, but it is important. So we call it affordance. For example, these look like buttons. These areas look like they are designed for pressing. Handle, door handle. If the door handle is vertical and with pipe like this, it means you have to pull. If it is a panel, it means push, because there is no place to hold it. So if you want people to push the door, don't put a handle, because when they see the handle, vertical bar, they will try to pull it. It also is dependent on the culture and regional habits. For example, in United States, many doors are pull doors when you are entering to the stores, and push doors in between sections of the building. Double-sided push doors. So when people go to Europe from United States, and as in the case of Donald Norman, they have difficulty using the doors. That's especially interesting when the Turkish people go to United States. They try to enter the stores by pushing the doors, and they can't enter the doors. So if you see somebody in United States pushing the door and trying to get inside, you can conclude that he or she is European or Turkish, because push doors are more common in this area. With the pull handles, the handle is pull type, but the working mechanism is the push type. So we call it as, please click me, appearance is called as affordance. A good interface has affordances, so we perceive affordances and then we use the interface. The second thing that Donald Norman tells us is the mapping. For example, this is a stove. This controls this one. The other one controls these two. So you don't have to look for the signs. You don't have to discover which one is operating which. But due to engineering reasons, people use it this way to make it shorter. Some manufacturers have this kind of arrangement in the front, which is usable a lot. I think Franke has this kind of arrangement with the one stove in the middle too, 5 stoves. So if you arrange this way, no errors will occur. So by modifying the design, we can eliminate some errors. And it comes as free. Nobody makes mistakes anymore. This is from Mercedes car, a seat adjuster. So in order to move the head part, you push the head part up and down and forward and backward. For this part, you move this. For this part, you move that. Therefore, and up and down too, from here. Therefore, this is called as one-to-one mapping, like a mathematical function. So if there is one-to-one mapping, then the user interface becomes easy to use. For increasing some value, you move it to the right. Decreasing, you move it to the left. In order to move through the calendar, you move to the right. Increase, decrease, because in Latin speaking and Roman numerals, when you go to the right, it increases because this is 0. These are positive numbers, negative numbers, okay? So generally, our civilization, even if it is Arabic speaking, our civilization has right side as increasing values, left side is decreasing values. So when you do the same thing in the interface, it becomes easier to use because you will have one-to-one mapping or up and down. If something is increasing, it is up. Something is decreasing, it is down. Clockwise and counterclockwise. Clockwise and counterclockwise has an interesting property. For the water faucets, you turn counterclockwise in order to turn on the water. For the electronical device, you turn to the right, clockwise, in order to increase the volume, increase the brightness, increase the any increased temperature, increase any kind of variable. The reason is when you are using pipes, you need to unscrew. You need to unscrew the valve seat from the bottom. Therefore, you need to turn counterclockwise to unscrew the mechanical screw to turn on the water or turn on the steam. So that is different. But if it is piping valve, people usually, except some interesting cases, people usually think that you need to turn counterclockwise. Have you ever seen a bathroom, hotel bathroom valve with a single control? Let me show it to you. And at that time, you should think about this. Okay, I found it. I think this is it, but this is the one. Okay, I found it. Okay, this is another. Okay, so here is my example. Normally, we believe that the water controls are turned on by turning it counterclockwise. But this one, these hotel type controls are sometimes difficult to use because that is different from what we have been using in our daily lives if we are living in a different setting. So the one on the right, the one you see on the right starts from the cold and gradually goes to hot. And the one on the left combines the volume and the temperature in the single control. So also it is difficult to adjust if you are not used to, because the visible structure does not help. Especially the one on the right is more difficult to use. The one on the left has wait a minute. The one on the left has a handle. This handle tells you that you can pull it up and down. Therefore, by double action, up and down and turning, you can adjust the temperature. So it is not that easy. But the one on the right is more difficult. So it is the visible structure. Even the shape of the handle is important. For the computer programs, it is the shape of the button, shape of the link, shape of the image that changes the user behavior. You have seen it with the two matches. Try to look on the other side, and this is the solution. So the problem here is we don't always know how user thinks. So we don't always know what the user's habits were. When problems are represented poorly, user will have difficulty in solving the problem or will completely fail. If the user thinks and follows a different model than the presented model, then it will be very difficult to finish the task because the actual thing is different and what we think is different. When let me show you the model. Oops. Wait a second. Okay. Okay, this is the problem I had several years ago. I tried to turn this, and the one I had, this is little bit different than it has some pointing section, but mine was completely round. I tried to rotate it, it didn't work. And I couldn't turn it on. Then later I realized that I have to bend it forward and backward first, then bend it these two ways. So you have to bend it forward and backward, left and right, in order to adjust the temperature and the amount of water. So you should not rotate it. I was going to break it trying to rotate because I was young. I couldn't turn it on. I was in the toilet. It was very difficult for me because my mental model was about the faucets was the valves need to be turned to the left in order to function. I haven't seen the other one, and there was no visible cue. There was no visible cue for this thing. And later, this might seem very easy to many people, but it explains how we do things. Later, they changed the shape of the interface. When they changed the shape of the interface, actually, this one is a little better than I used because it is not completely round, but there are no colors and instructions or arrows on it. When you design the shape inconsistent with the function, users will not have that much difficulty. It is automatically understood how to use. So a computer interface or system interface must be like that. You have to automatically understand how to use it just by looking. So in order to increase the success, attention increases the success rate. So if you are paying attention, you will be more successful. So if you are listening to this class, you will be more successful. Big changes, if you make the changes, if you make the information big enough, then it will be okay, düştüm geldim. Make it big. The Ferrari below has a speed display here, additional accessory speed display here. So you can see your speed easily because you are looking at the road as you go very fast, and heads-up displays starting from the airplanes and fighter jets. Now they are available in the cars and other equipment. Increases the chances of getting enough attention, getting more attention, because the information is placed in the direction of where you look at. The new Apple Vision and Google Glasses and Microsoft HoloLens setups, they all try to combine the information with artificial reality on top of the information coming from the external world, and they put the information where you look at, because they have eye trackers, and Apple Vision has eye trackers inside as well. Also, the last thing, we can ignore visual signals, but we cannot ignore auditory signals. If some light is turned on, red light in the dashboard, I can ignore it because I know that it is not functioning and I can live with it. But if it is giving me a sound, alarm sound, I have to pay attention and I have to fix it. So if the problem is if the problem is important and will require attention immediately or sooner, you should support it with the audio feedback so that user cannot ignore it and must respond to it and turn it off. Let's give 5 minutes break because we did some an hour. Let's give 5 minutes break and come back in 11:45. Okay. Any questions from the previous class? Sorusu olan var mı? Oradasınız değil mi? Tamam. So now I'm going to talk about metaphors, user interface metaphors. It's defined as an entity from real life that is visually represented with an image or an object. So it is not the real thing, but it is the representation. Like the puppets they make for the voodoo magic in the films, in the traditional traditional medieval times. They make a puppet of the real person, and they make magic on the puppet, and the real person is affected. They believe that it is affected. So that is what we say metaphor. It's a representation. That representation, the metaphors are used in the icon design. Representation. To create the understanding of cutting with the scissors, create the image of writing with the pen, with the symbol of the pen, with the metaphor of the pen, create image of employee list by placing as a person's head, or it's an employee menu. How? There's a person. So there are three types of visual reference to start with to metaphors. One is the icon. Second is the index. Third, the icon of the fire. Index is the cloud and the fume made by the fire. So by showing the fumes and the cloud, dark black clouds, you refer to the fire. So that is what index means. Indirect relationship. Symbol, on the other hand, is modified version of the icon. At the beginning, there could be a relation, but the relation is weakened so much that maybe there is no relation at all. At that point, there is no relation. So it becomes like a pictorial alphabet. Like Egyptian hieroglyphs, we have icons and indexes, but some of them turned into symbols, like rectangles, like sticks, like triangles, or symbols. And actually, the shapes of the letters, today's letters, are formed largely from the Egyptian hieroglyphs to Phoenician alphabets. Phoenician alphabets is Phoenike. Phoenician alphabet is the origin of the Latin alphabet, where we have names of the letters related with their shapes. For example, letter N is the name of the snake. Okay. The B is for house, where you have 2 rooms. Okay. And in Old Turkish alphabet, I think this is R, right? In Göktürk alphabet, that is R, and it is pronounced as R, and R means man or soldier. So it represents the person. Therefore, the roots of the symbols and letters goes back to their pictorial meanings, and the interfaces and design of icons, we follow the same rules. We try to get away from index. Index is kind of dangerous, so we try to follow icons and symbols as much as possible. There are design issues with the icons and the symbols. Rektörlükten arıyorlar bir saniye. Efendim. Teşekkür ederim. Dersteyim ama acil miydi? Bir de görüşebiliriz. Tamam. Kolay gelsin. Bay bay. So this design is the perfect one. In this one, you have too much white space. So the balance of dark and white space is not good. There is an asymmetry problem here. Incorrect balance between edges and the actual image, and improper scaling. So these are all important. When you are designing an icon or symbol or designing even a button, you need to pay attention to these small details. Otherwise, the perception of the interface will be bad. Bad means low quality, incorrect. It depends on how you do it, but generally bad. And typical examples, a fire button where they refer to the hat of the fireman. But what if the fireman hat is not known by the user? If the country is not using this type of fireman hat, people don't know. People will not understand immediately, because immediate understanding is important. They may learn, but learning is something else. Immediate recognition is important. This mail, this is a United States mailbox, but if you live in Europe and Turkey, we don't have this kind of mailboxes, and postman doesn't use this kind of mail delivery system where you have the flag goes up. If the new mail comes, postman delivers this, it puts the flag up so that when you look from outside, look from inside, from the window, look at the mailbox, and you see that there is no mail. Because if there is mail, the flag must be up. And these mailboxes have 2 sides. There is another side at the back where you use for picking up the mail. If you open this door to pick your mail up, this flag drops. In some models, you drop it manually. In some other models, it automatically drops. Therefore, mail is emptied. So this metaphor can be used by some user interfaces in mail programs, right? Mail programs, but If you are not from United States, you are not familiar with this icon, and you will have trouble because you don't know the flag issue. In the old workstations, like Sun workstations that we used, the mail client was actually using X Windows. Mail client was using this flag to indicate whether you have new mail, new email or not. But if you don't understand what that means because of the familiarity problem, then you will get an issue. Typically, this is a door smart home, early smart home mechanism. Some control. Where is my cursor? Okay. Key metaphor, phone, melody type, TV. Who knows? This is indirect. Some text message and light. It's okay, but these are not fitting to the screen, so it had some slight design problem, but we can live with it. This is probably lock. We usually confuse between lock and key. This is actually key, but key symbol is associated with locking. So how do we use them? How do we generate metaphors? The metaphors must be immediately recognized. What is this question should not be asked. If it's an image-based, usually it is, image of a cat should not represent our cat. It represents all cats or all animals. So some generalization must be conveyed, should be implemented, and that is done through iconization. We don't use pictures for metaphors because when you use a picture, for example, if I use the picture of Ersel, merhaba Ersel, if I use the picture of Ersel as a student icon, yes, thank you, it is not going to work because it only means Ersel. It doesn't mean the student in general. So if I am going to mean student in general, I have to make a general student picture which doesn't correspond to any particular person. So it shouldn't look like a picture. Okay. Third, associativity. When they are used together, they are perceived as a combination of a bigger system, such as arrows. If you see only one arrow, it doesn't mean anything. But when you have these three together, you immediately recognize that it is forward, backward, play, etc. So it is associated with playing and going forward, going backwards in the search engine, maybe in the search results. So backward, forward, automatically recognized when they are used together. And characterization, the information content. This is important. Information content of the object should not be used indirectly, not through details. For example, Mustafa Berk has glasses. Okay, Mustafa Berk has glasses. So if I am going to talk about glasses, I shouldn't put image of Mustafa Berk, even if it is in iconic form, because I should put glasses, not the person. So the meaning should not go through details. The meaning should be direct. Therefore, I should put glasses only in order to give the glasses menu or glasses selection. So the indirect explanations through details must be omitted. And the cultural communication background, the designer and user of a metaphor should have similar cultural or educational backgrounds. That was an interesting, there was an interesting time where Apple computers have trash cans rounded. But in our country, trash cans are rectangular boxes. So nobody is using round trash cans. So one of my friends, this is real, by the way, one of my friends always thought that symbol was the battery symbol. Okay? Let me find it. Okay, so this is the macOS trash symbol that we have been using over the years. The first one was in 1983. I have used it in the old days. And the thing I was referring is this one. My friend was thinking that that was a battery, not the trash. So for probably several years, he thought that it was the battery symbol, and he argued with me. And later he realized, and it was very funny when he realized it. So why didn't he realize it? Because we didn't have that kind of trash cans in our country. So when we see it, we don't realize it. We don't associate it with the trash. So cultural differences, communication ability, meaning that designer and user of metaphor should have similar cultural and educational backgrounds, is important. So sometimes you need to design different interfaces, different icons for different countries, because in that country, that object is not common, like a mailbox, for example. In Europe, mailboxes are different because many people live in apartments, so they're more smaller and small boxes, etc. So we use envelope for that. For saving, we use the floppy symbol, right? We use floppy symbol, but this floppy is not being used for at least 15 years. Therefore, our generation remember the floppy disk, but new generation doesn't know what floppy disk is. So I am expecting the save icon to be replaced with something else in coming years, or we can assume that this turned into a symbol, like the Phoenician alphabet letters, where letter B corresponds to the house. Nobody thinks about it today. Nobody knows about it today, but we use letter B for another purpose, for giving the sound B, giving the letter B. That's today's latest one. And another confusion is Apple calls it trash. Microsoft calls it recycle. Some users don't want recycle because when they are told that their documents are recycled, they think that it is going to be used again. Somebody else is going to use it. So they try to not to do it because it is associated with recycle. They want the document to be trashed, not recycled. So I have read an article about it, and the article says the word recycle is not good for document erasing because it's not recycled. This is another example from an airport. Departing planes, incoming planes, outgoing planes. So there is an arrow. But the problem is the plane is seen from top, arrows seen from sides. So you have to have plane going up, plane going down images taken from sides, not from top. This is another incorrect design example. Other examples are usually going through details. The problem is going through details. This is from the book. That's why they are white and black and white. This is very famous. This means exit from Windows. Exit from Windows. Talk to hang up for talk. Hang up to disconnect. So going through detailed actions. Go down, go up. Okay. So these are too detailed. Those details cannot convey the meaning automatically, and we can't understand them. This is another mistake. In order to create an illusion of the feeling of uniformity, they put too much uniform details. When you put too much uniform details, like this, that part is lost. Only this part is to be understood. In that case, you lose valuable icon space for nothing. They all look similar. Yani lojman gibi birbirine benziyorlar. Bu sefer anlamıyorsun. So too much consistency is not sought. Sometimes people can't find images and it becomes easy to put words instead, such as save, new. So text that is converted to image sometimes. Too much use of text is also problematic. If the task is complex, use of images may be not proper, such as insert into middle. These things may not be easy to understand because the action is too complex. When the action is too complex, icon and metaphor representation may not be preferred. It could be text menu. And relationship is sometimes incorrectly set. For example, this is pick. This is cut. Balta koyuyorsunuz cut için. This is anchor, point, tag. I don't know the others. And hello world. Screen dump. Secondary meaning and cultural problems. Defaults. Shelves. Jar. Back burner. Okay. Drag on. So these are indirect and cultural dependent examples. I like this one, screen dump. This is dump truck and dumping, and it says screen. So language and cultural problems associated with icon design. And also improper language like rest in peace, kill, shoot. These are not good examples for not good examples for associations, because those are improper actions. So how we do it? How we do design the metaphors? We should design with the correct method. What is that? The basic one is the incremental abstraction. In the incremental abstraction, you start from the image and you slowly reduce details so that it becomes an icon. Start from the image and eliminate details step by step. So generally, you need metaphors, multiple metaphors at the same interface, such as we have 1, 2, 3, 4, 5, 6 metaphors here. So these metaphors have similar language, similar compatible language. The level of details are similar. So coordination must be done to provide visual compatibility among metaphors in a user interface. And this is a successful example. This is the party mode. What is this? Tell me. That is saving mode, right? But since the pig is not a common animal in Turkey and the pig money boxes are not common among children, so a penny on top and the pig box will not be understood in Turkey. It could be understood in the United States, but not here. So maybe İşbank money box or a money symbol, okay, dollar symbol, could be a better alternative. Here is the party mode, but if you are not doing partying that much, it may not be understood well. But it is given as red. So red is associated with more power, more consumption. So even if you don't understand the glasses, the colors will help. Also, this is green. The pig is green, pig box is green. Therefore, it helps to some degree that it is more eco-friendly. So this is a good example. If the concept has a strong base meaning, it relates to a familiar object that is tangible, understandable, icon should be used. If this concept is used several times in the application, symbol or index might be a better idea. It is better to relate them from real life if possible. Otherwise, symbol. If the concept describes more abstract process or state change, then labels should be preferred. Mixing icon, symbol, index unnecessarily together can cause usability problems. For example, here, they're all from the same family. If you use one icon, one symbol, and one index, then you create problems. And doing incremental abstractions. Start from a complex image, start making it simpler and simpler, stop at some point. Following original lines, simpler drawings are obtained incrementally. Only important details are drawn at each step. After several trials, best representation can be selected. Complex shapes should be converted to simpler geometries to be understood. Contour lines can be eliminated and background color can be used instead of the certain cases. So lines can be eliminated. For example, start from the photograph, convert it to drawing, then convert it to caricature, switch to outline, and silhouette. So these two maybe is the actual meaning in the icon. And if you are designing a software and designing your own icons, start drawing metaphors after all initial images are obtained, because they have to be done together. Some same perspective and viewing angle must be used for each metaphor. That dot fit must be redrawn. So if you are looking from the top to each object, all of them should be looked from the top, not from the side. Same level of abstraction should be preferred. Always, we should use consistent icons with respect to size, orientation, drawing styles, color, visual weight, etc. So they should look like from the same family. And use same components in all metaphor library, same lines, same curves, same patterns, and other shapes. So consistency in the interface must be preserved. Okay, so I'm now going to briefly talk about the text. When we use uppercase, it is harder to read. Therefore, it is good for labeling. Lowercase is better for reading. Serif fonts are better for reading. Sans serif fonts are better for titles, labels, etc. So if the interface is requiring a lot of reading, then sans serif font is better. But if it is short explanation, sans serif, meaning that not serif, this means not. Non-serif fonts are better for titles, labels, etc. Italic and bold is also interesting for emphasizing certain parts. When the line length is too big, it is possible to skip the line due to extreme field of view of the line. Therefore, having multiple columns in a page is good. Don't make the line length too much because people cannot read it. So language in the interfaces. If you don't pay attention to the language, people will make mistakes. This is sometimes due to error management because you are collecting the error text from another place in your application, but you should pay attention to what you say to user because it is not understandable and people will make mistakes, such as okay not to save game. Okay, cancel, save. What? Okay. Words in the interfaces that therefore must be validated by several end users, not engineers. The words must be selected from users' vocabulary, not the designer's vocabulary. Abbreviations must be carefully selected and understood by end users. When read out loud, meaning should not shift or change. Sometimes there are abbreviations. Those abbreviations should be read out loud. Words must be compatible for young and old generation and for different cultural backgrounds, such as yes, okay, dismiss, validate, confirm, continue. So you should choose appropriate common letters, not your own jargon. And icon support might be helpful if the language problem exists. When you are doing a multi-language device and it is impossible to change the language because of certain limitations, then try to support it with more icons so that even if it is in English, icons will recover in case of the problem. Although it is not as good, it will help. Today we see some English dominance in the interfaces and incorrectly. For example, upright süpürgeler, rice center, all rice reserved in a Turkish website. This is a French site, but it says helping led the way. Cafe. Okay. Creation by Magicalic. Property. So unfortunately, there is some dominance. We look like we behave like it is understood, but some people don't understand it. Some people don't understand it. Such as this. There is a swap button. Swap is an interesting function. Also, smart, hold. This could be universal for young generation, but for many, that is not understandable. So that part of the interface remained, that part of the interface remained unused. In some interfaces, there is language change button, and those are represented with the country codes, which is somewhat standard and understood. Okay. In the coming lecture, I am going to focus on principles of user-centered design. We will talk about task analysis, iterative approach, and real user tests. What is user-centered design? It is this: task analysis, requirements, usability tests, principles, and HCI, experience. They all go to design. Then you develop the application. Then you evaluate. You evaluate and you change your design again. So through the iteration, multiple times, you end up a better product. If you don't do iteration, you don't get a better product. This is defined in ISO 9241-210. If you type to the internet ISO for 9241 to 210, you will get this model. Okay. So this user-centered design is the modified version of the structured software engineering. It's a part of the software engineering discipline. It treats users as members of the software development team and makes collaboration in many stages of the development. I am going to move on that part next week. If you have any questions, let me know. Okey arkadaşlar. Taptı.